in this video, we'll be showing how we can use MCP and AIs to autoscale a Kubernetes cluster. So you can see we have a Kubernetes cluster that's ready, which has one control plane node and one worker node. And we also have a Grafana dashboard showing the information on the cluster. So the first thing we want to do is to try to stress up the CPU usage of the cluster, so we can demonstrate how the AI is able to scale the cluster. So here we have the MCP server of the autoscaling machine. So here we can look at the tools that we have in this server. So we are able to see that we have tools to create these instances using Terraform from different cloud providers like GCP, AWS, and Azure. And then we are using Kubespray to add the instance to the cluster. And one thing to note is that when we have the input for these tools, the AI will be able to identify them and add in these inputs as they are. And also one thing to note is that the description is pretty important here. So for instance, when we add a description saying that adding the nodes into the cluster should be executed only after the work node is created from the cloud providers. So the AI will be able to identify this and do the steps necessary. So we also have the tools to scale down the cluster. So destroying the instances from the cloud providers and also removing the node from the cluster. So also we can see that this tool identifies which node to be removed, and so destroying the instances should only be carried out after the node is removed from the cluster. So the AI will know this and will execute this tool first before executing the destroy function. So in this server, we also have some other tools like checking the cloud price. So what this does is that it will get the lowest on-demand instance price from the 3 cloud providers. And also we have a function which does checking the CPU usage on the Kubernetes worker nodes. And if we look at the MCP client, we can see that our query is that we want the AI to monitor and manage the Kubernetes cluster and scale the cluster in a cost-effective manner. And so I'm just gonna do this part. So by looking at this query, we'll be able to see that what we want the AI to do is that we want it to monitor and manage our Kubernetes cluster and scale the cluster in a cost-effective manner. So just by telling the AI to monitor and manage the Kubernetes cluster, is going to execute functions that will check the CPU usage and also other queries that you want to do to the cluster if it's defining the autoscaler servers. And by saying scale the cluster in a cost-effective manner, it will know to check the prices of the cloud provider and then choose which one to use to scale the cluster. So to do a brief demo, we can execute this client while the cluster is in a pretty healthy state, we can see what the AI does and the reply of the AI to see if it's able to carry out its duty and if it will scale the cluster even when the cluster is in a healthy state. So this will take some time. Yeah. So this part is just showing the tools, or like the AI is getting the tools, like it's accessing this server and displaying the tools that it has access to, and then it decides which tool it's going to use. And this part is actually calling the tool that it wants to use. Okay, so we have a response from the AI, and we can look at that. It's pretty messy, but we can look at the response here. So what it says is that given the current CPU usage and cost-effective option from here as the next step. So it says continue monitoring the CPU usage, and if the usage consistently exceeds 70 to 80%, scaling up may be necessary. So what it does is that, so it asks you if you like to add a worker node or like continue. So it, like, based on the AI's judgment, it's not scaling up for us. So now we want to try if it will scale up for us if we if the cluster is actually above the 80% mark that it mentions. So we have a node, so we have a pod that allows us to do this, which we're going to deploy onto our cluster. Oh, sorry. I'm going to set this to 1. So let's wait for a little. Okay, so we have this pod that's being deployed, and we can look at our dashboard to track the CPU usage of the worker node. Okay, so we are able to see that the CPU usage of the worker node is ramping up. Okay. Okay, so now we have the cluster which has the worker node fully throttled. We can check to see if our AI is able to scale up the cluster. Sorry. All right, so as the program is executing, so when the AI is calling the tools to scale up the cluster, we can look at the dashboard to see the changes of the of the CPU. So now we can see that the utilization rate of the worker node CPU usage has been lowered. And now we can check the response from the AI. So what it says is that so this node has been successfully added to the Kubernetes cluster. The scaling process is complete and the cluster should be better equipped to handle the current workload. So we can see the actions that the AI did. So it identified high CPU usage, and then it said cost-effective scaling. So it selected GCP as the cheapest provider. So by calling the tools, it determined that GCP is the cheapest provider. And then it used Terraform to create this new node. And then it added this worker node to the cluster. And we can check our Kubernetes nodes to see if we actually have a new node. So that's good. Now what we want to do is to remove this stress pod, and then we try to scale down the Kubernetes cluster. So we'll change this to 0. So after this is terminated, we can check the Grafana dashboard. Okay, so the pod is now terminated, and we can see the CPU is lowering down. So as we have removed the pod, we can see the CPU is getting smaller and slow burning. Now that we have the CPU usage for the worker nodes lowered, we can try to scale down the cluster. So now we still have the scaling nodes at sync, and we'll just execute the scaler client to see if it's able to lower the So now that we execute the autoscaler client to see if it's able to scale down the cluster for us. So now we are able to see that the cluster has removed one of the nodes. And then we wait for the whole operation to finish, including removing the the instance from GCP. So right now we still have the scaling node, and after it's been removed, we should see it's gone. Yeah, so the node should have already been removed by Kube3 from the cluster. And now we just wait for the Terraform to get rid of the instance. Okay, so now see that the operation is finished. You can check that the node has been removed, and again, so we see that the total CPU has been decreased, and we can see what the AI told us. So here's a summary of the actions taken. So the node was safely removed from the Kubernetes cluster. The associated GCP instance was terminated to avoid necessary costs. And the cluster CPU usage is consistently low, indicating underutilization. So yeah, so this is a demo to show how we can use DeepSeek AI to do autoscaling for us. So if we were to put this to real use, probably we can hook this up with like a webhook or with a alert that our monitoring system has. Or we can set up a cron job for the tool to check out the cluster periodically to see if we need to do scaling. So that's all. Thank you.